In this lab today, we're going to look at the ideas of abstraction and encapsulation and see how they can be used to create a very simple ciphering application. You should be all logged in to Moodle to CRN 45623 Advanced Object-Oriented Software Development. And if you scroll down under the Object Lifecycle Review of Basics, you should see a lab here applying abstraction and encapsulation. So I'm going to go through this in this video cast. The actual finished result is here, but you really ought to go through the steps I'm going through now because there are a series of refactorings that are done, and you really should know how this works. So I want you to just download the PDF, and I'm assuming that everybody has read all of this. Okay, the basic forms of abstraction: role, interface abstraction, hierarchical abstraction, i.e. is in abstract classes, those ideas, and the notion of a single responsibility principle, how that puts you in a hierarchy of responsibilities, and just using basic class abstraction like the string class in different contexts. And you should be well familiar with this. In terms of encapsulation, then different ways of doing this: the levels of encapsulation, the simple notions of information hiding, visibility with visibility modifiers and constructors, mutability of objects using defensive cloning techniques, and deep cloning to prevent indirect access to mutable objects, using inner classes not only to hide an implementation but to hide the type completely, separate classes, and even things like deployment descriptors, or XML, or some form of structured text, something like that, and i.e. get the dependency out of your application entirely into an editable, peripheral file that users can configure at runtime, or sorry, before they go to run an application. So we're going to go through these exercises here and a series of, going to create some classes, go through some refactorings. What we're going to do here is not going to be pretty. The whole point of doing these exercises is to identify what is good practice and what is not good practice when we're developing applications in an object-oriented language. Okay, so the first thing you're going to need to do is you're going to need to open up Eclipse and create a new project for yourself. And I'm going to create a new Java project. And this project I'm just going to call Abstraction ENC for encapsulation, and I'm going to finish. I'm going to expand the project, right click over the source and create a new package, and I'm going to call that ie.gmit.sw for the software people. Okay, so the first thing is to create a new type called cipher exception that is a subtype of java.lang.throwable. So we'll do that here. We'll right click over a package, go to new, and create a new class. What is our class? I'm going to call it cipher exception, and it's a type of what? Well, it's a subtype of java.lang.throwable, Throwable. Throwable is a super type of exceptions, all exceptions. The class exception itself is a throwable. A throwable is merely something that can be thrown. So we'll just hit finish here, and we'll see we have our own exception. Now we have a warning here, and that's because the throwable is serializable. Therefore, we should, to get rid of it and get it to compile, implement a serial version UID, and I'm going to go to all the lucky sevens here. Pick a number and be consistent with it. Control S, save it. And the basic idea here is we want to try to get the code to compile all the time. Okay, we'll break whatever rules need to be broken in order to do that, and eliminate warnings. Have a nice clean build each time. Okay, so that's the first thing done. We've cipher exception is created. Now the next step is create a class called Caesar Cipher. Now Caesar Cipher is named after Julius Caesar, who basically used a cipher to encrypt his communications during the Gallic Wars between 58 and 51 BC. And it's basically a simple shift cipher where you have a number, say 3, so the letter A would be 1, 2, 3, B, C, D, that kind of idea. And we could reverse it, so the actual number becomes the key. So create a class called Caesar Cipher with the following methods. Now, Caesar cipher is fine when you're dealing with illiterate Gauls in the 1st century BC. Again, folks, we're going to return null here, okay, to force everything to compile. Okay, we'll break whatever rules need to be broken. So, 1st century BC, your average Gaul was illiterate. So, really, the Gallic Wars, or the Belgo-Gallica, the encryption was really used there to hide Caesar's dispatches from nosy Romans. He published it as a book at the time, and it was in fact a bestseller. Okay. Of course, it did hide the fact that at least 2 million Gauls died during the wars, but it's neither here nor there. History is always written by the victors. Okay, so here we've got effectively class Caesar cipher with some encrypt methods. It's overloaded. One takes in a string plain text and returns a string. The other takes in a byte array and returns an encrypted byte array, and we have decrypt versions of those two methods too. The class should also inherit the finalize method, override it. So we're going to do that now. So I'd like you to go up to source, override implement methods, and we're going to select finalize here. And we'll just do something as follows. Finalize method is going to be called when this object goes out of scope before it's garbage collected. So I'm just going to do a sysout, and we're going to say that Caesar cipher and we put in the ID plus this, we'll call to string on this object, is about to be gseed, garbage collected. Calling this, or this will result into string being called, which will effectively append the object ID, including the full class name, fully packaged class name, to this string. Okay, so we've done that much so far. So next, add an instance variable called key of type int to the Caesar cipher and make sure the visibility modifier is set to public. Now, folks, this is a really bad thing to do. Public int key. Okay, now key is going to be initially assigned a value of 0, and that is visible from outside the class. We are breaking at a very simple level our first layer of encapsulation, which should have at least our inner class members protected, i.e. they should always be private. Okay, so implement the encrypt and decrypt methods using the value key to change the character at each index of the plain text, okay, to its plus or minus key value. That's fine. So let's start with this. Encrypt. So what are we going to do here? Well, if you call encrypt and pass me in the string, I'm going to return whatever I get back when I call encrypt. I'm going to get plain text dot get bytes. That's going to return a byte array to me. I'm going to wrap that now in a new string, and that should work fine. And likewise, now I shouldn't be copying and pasting, that's bad, but we do it in this lab. For decrypt with the string, I'm going to use the same thing here. So instead of plain text, it's going to be ciphertext, and instead of encrypt, it's simply going to be decrypt. So how is this going to work? Well, I'm going to return the byte array here, and I'm going to return the byte array of ciphertext here. These are stateless methods. They're not the string plain text. It's passed me in something here, and something else has been passed out of it, but the class instance variable is just key. The state of the class itself, or the object, does not change. So let's go and implement this then. So what are we going to do? We just type in for, be good and lazy, control space, let Eclipse do the running for you now. Iterate over an array, that's what we want. And what do we want to do here, folks? What I want to say now is that plain text, the ith element in it, is assigned the value of what? Well, cast to a byte, because it is a byte array, okay? Whatever we get back, when I go plain text I, and it's encrypt, so I'm going to go plus add my key. That'll do fine. Okay. And what about decrypt? Well, again, it really should not be copying and pasting, but this is rather straightforward, so it shouldn't be too problematic. I'm going to look at the ciphertext, and instead of adding the key, we're just going to subtract the key. And for the moment, that's our Caesar cipher implemented. The final thing now is create a new class called cipher runner and use this to basically, first of all, set the value of the key and then do some encryption. So let's do that. So we create a new class called cipher runner. And we'll put a main method in here. And what I'm going to do here is make sure that the main method throws a throwable. Okay, so we're going to go Caesar cipher. CC is assigned the value of a new Caesar cipher. CC dot key, I'm going to set the skip value to 7. And I'm going to do the following. String S is assigned the value of what? CC dot encrypt. Encrypt what text? Well, let's pass it the text object ORIENTED. And then I'm going to sys out the encrypted text. And then what we're going to do, folks, is we will output the decrypted text by calling Caesar cipher.decrypt, and we pass in the string S. And we just put a little heading on this first. To keep it nice and tidy. Okay, so let's run that and make sure it works. So run as a Java application, and we'll see that that works. Here's our encrypted Caesar cipher, shifting down each letter by, in this case, 7, and our decrypted value is back again. We know it works. Okay, the last thing we're going to do in this part of the lab is to change this variable here from public to private. Okay, this is a disaster here. Anybody outside can has direct access now to a class, an inner member. So I want to make sure this thing is protected so it can be controlled. So I'm going to select the class, the instance variable, the name, and I'm going to do the following, folks. I'm going to go to encapsulate and find it. Encapsulate field, and the field, we're going to put getters and setters here, get key, set key. So I'm going to click preview, and this way refactoring works. Here is before and here is after. So I'm going from public int key to private int key. I'm going to have get key and set key. And finally I'm going to have my runner here. I'm going to have cc.key, break encapsulation, cc.set key. Much better. Allows me to have some modicum of control. So I'm going to click OK. And we notice, folks, that's changed, and our runner again has been changed to with the set method. So we'll run everything again just to make sure it actually works. And we find that it does work. So that refactoring worked fine. And again, folks, we should remember refactoring is a process of changing the structure of a set of classes